Welcome to The Explainer. Today, we're diving into Ohm's Law, a rule that sounds complex, but is actually so simple and so powerful that it forms the foundation for pretty much all modern electronics. So here's a funny question for you. What can a simple garden hose possibly teach us about electricity? Well, it might sound a little strange, but it turns out the best way to understand the invisible world of electricity is to think about something we're all familiar with: water. I want you to picture this. Electricity moving through a wire is a lot like water flowing through a hose. Seriously, this one simple analogy is really the key to unlocking one of the most important concepts in all of electronics. Okay, so let's start there. We're going to build out this mental model, drawing a really clear comparison between the flow of water and the invisible flow of electric charge. This is where it all starts to click. Think about it. The pressure of the water pushing through the hose, in electricity, we call that voltage. The amount of water actually flowing past a certain point, that's our current. And what about any kinks in the hose or a narrow pipe that slows things down? Yep, that's resistance. All right, now that we have that water analogy in our heads, let's get a little more formal and properly define these big three concepts: voltage, current, and resistance. So first up, we've got voltage. The easiest way to think about it is as the electrical pressure. Just like turning up the tap gives you higher water pressure and a more powerful spray, a higher voltage pushes electrons through a circuit with more force. Next is current. This is all about the flow rate. You can think of it as asking, how much water is flowing past me every second? In a circuit, we're measuring the flow of electric charge, and we do that in a unit called amperes, or just amps for short. And rounding out our big three is resistance. Now, this is anything that opposes or gets in the way of that current. If we go back to our hose, it's like pinching it with your thumb or trying to force all that water through a tiny, narrow pipe. It's the opposition to the flow. So now we've met the key players: voltage, current, and resistance. Let's see how they're all connected by this really simple, kind of beautiful rule that was discovered by George Ohm. And here it is. This is Ohm's Law. It's amazing how simple it is, right? Voltage equals current multiplied by resistance. This one little equation is, and I'm not exaggerating, the absolute bedrock of electronics. And you know what? There's a fantastic little visual trick to help you remember it so you never have to mess around with algebra in your head. It's this simple triangle, and it holds all three versions of the formula. Here's how it works. Let's say you want to find voltage. Just cover the V with your finger. What's left? You've got I next to R, which means you multiply them. What if you need to find the current? Okay, cover the I, and now you see V times over R. That means you divide. It's really that easy. Or, hey, if the triangle isn't for you, there's a sillier method that works just as well. Just imagine you're in a car, and you have to slam on the brakes. What's that sound you make? Vroom. And there you have it. V equals R times I. I bet you won't forget that one. Okay, so this is way more than just a theory, right? How does this law actually help us in the real world? Let's walk through a practical example together. So have a look at this. It's about as simple as a circuit gets. We've got a power source, a 12-volt battery, and just one resistor that's providing 600 ohms of resistance. The big question is, how much current is actually flowing through this loop? Well, thanks to Ohm's law, this is super straightforward. We want to find the current, which is I. Our handy triangle tells us the formula is I equals V divided by R. So all we have to do is plug in the numbers we already know. And this is the magic of the formula right here. You take those 12 volts, you divide by 600 ohms, and bam, you get your answer: 0.02 amps, which, by the way, is the same as 20 milliamps. Problem solved. And look, this isn't just some abstract math problem. This exact calculation is what engineers and hobbyists do every single day. It's how they figure out the correct resistor to use so they don't accidentally burn out something like an LED in their projects. It's incredibly practical. So let's step back for a second. What's the big takeaway? Why does this simple little formula matter so much? Well, Ohm's law is so much more than just a formula. It's basically the language of simple circuits. It's the tool that allows us to not just build things, but to actually understand, design, and even troubleshoot them. It truly is the foundation that all of electronics is built upon. Think about it. This simple relationship between three little variables is what allows us to create the incredibly complex technology that powers our entire world. And that kind of makes you wonder, doesn't it? What other elegant, simple rules are out there? just hiding in plain sight, governing the complex systems all around us.